Good morning, everybody. Just a reminder before we start, tomorrow's we are going to have review sessions. These are not discussion sessions. These are review sessions. So you will also have a discussion session tomorrow. But this is, I'm talking about the review sessions, the review of the material that you have, that you should have taken in 503, EE 503, that is relevant to our course. We are going to have the first session at 7:30 to 8:50 a.m. in the same studio. And then we continue. This is not repetition. This is continuation from 5 to 7 p.m. Now, in between, there are like 9 hours. I will have office hours, 9 hours. 9 hours, office hours. What am I going to do? So I will be in my office. If you do have any questions or something, drop by. Clear that the reason that these are the times, these are the only times that the studios are available. Clear, the studios are available. Now, the sessions, both sessions will be webcasted. So if for any reason you cannot attend, you can watch the webcast. However, I do strongly encourage you to attend the classes so that you can engage in discussions with me and so on and so forth. Okay, good. Let's continue our review. We will start actually the review from now, and then we will continue. I need to finish it very quickly before we start with the discussion of the quality of services. Now, we started looking last time at the general queuing systems. And let's review them, the components quickly. We have first of all, the population. The population, which means what? Which means whether it's what? Finite population or what? Infinite population. And I will show you, by the way, in the class and in those review sessions, examples of both finite population and infinite population. By population, I mean what? Who are the sources that are generating the traffic? So, for example, if you look at the model of the internet, you most probably you will assume that it's infinite because it's extremely what? A large number. You can model it as what? Infinite number of sources. Then we do have the arrival process. Arrival process, when the packet arrives from all of these customers into the router. You know, most of the time in this course, again, we will model them as what? As a Poisson arrival. Clear? Okay. The arrival process is Poisson. Then we do have the what? We do have the queue or the waiting. The queue. And in here we have what? Finite size. Or what? Infinite size. Infinite size. This again, this is the capacity of the queue. How many packets can there be in the queue? Okay, and then we do have the what? We did have the what? The servers. Servers, we have what? Single server. We do have what? Multiple server case. And then we do have the other type, the other parameter is what? Is the service times. Now in here we will look at 3 types or 3 examples. First one we will look at exponential. We will look at what? Deterministic. And we will look at what? General distribution. And general distribution means what? The question will give you what is the distribution of the service time. Okay. And finally, the last the last parameter or the last description of the queuing system is the queuing. Discipline. Okay, so for example, first come, first serve, a priority queuing, random queuing, and so on and so forth. All of these, again, you should have had it somewhere in 503, except for priority queuing. Priority queuing is not part of 503. So when we get to the priority queuing, I will go a little bit what? A little bit slower so that you understand it carefully. Priority queuing means what? Means the packets are not going to be treated the same way. There are some packets of higher priority, some packets of what? Lower priority. The queue will what? The server will serve them based on their priorities. When we get there, we will slow down a little bit. But the rest, you should have had it. So I'm going to go over it in detail so that you refresh your memory. For those of you who took 503 with Professor Sonis, you should recognize all of these things. But for those of you who took the 503 with other professors, I'm not sure. So let's see if you can follow me. Let's start with the first case, which is the simple case, case 1, or model 1, if you would like. We refer to, by the way, in general, the notation, before we get to the case 1. It's notation. We refer to it as what? A, B, C, small c, K, D, and Z. Let's use this. This A is the what? Arrival, process. The B is the service, process. C is the what? Number of servers. K is the what? The capacity. Maximum capacity of the queue. D is the what? Discipline. And Z is the population. So this is in general the notation like this. Clear? Okay. Now, let's start with something. First of all, let me introduce you to a very important formula. SI. Let's see if you have seen this. Very important. Let me, I need to refresh your memory here. Okay, first of all, what did we denote the, let's see. N, what did we denote the N? N is the number of what? Packets in system. Both what? Waiting and being what? We did this one last time, but I'm just refreshing your memory. Okay, N, W, or any Q if you would like, doesn't matter. Number of packets waiting. NS is what? Number of packets being what? Being served. Clear? Question. Are all of these random variables? The number of packets in the system, the number of packets waiting, the number of packets being served, are all of them random variables? They are all random variables. Now, how they are related? N is equal to what? NW plus what? NS. Keep that in mind. These are as far as the number of packets. Now, also, what did we define? T is the what? Total time spent in the system. Again, when I say spend in the system means what? Both waiting and being served. Both waiting and being served. W is the what? Waiting time. And S is the what? Service time. Question. Are all of these random variables? Are all of these random variables? They are all random variables. The T, the W, the S, are they all random variables? Yes, they are random variables. And how are they related? They are related by what? T equal to what? W plus what? S. Keep that in mind. Clear? These are all the notation that we will be using in defining our models. Clear so far? Okay. Now, at steady state, equilibrium, we have what is known as what? Little's theorem. Little's theorem or formula applies. I will show you what the theorem means in just a second, or what is it in just a second. Applies for every part of the what? Of the Q. For every part of the Q. The Q now is this. This is the Q. This is the what? The server. So this is the Q. This is the server. And this is the what? The queuing system. Okay, what is Little's formula? Little's formulas tell you the following. E of n. What is E of n? E of n in words. What is E of n? E of n is the average number of packets in the system, both waiting and being served, is equal to what? Lambda times what? E of t. What is lambda? Lambda is the average arrival rate. Units what? Units what? In packets for what? Second. And what is E of t? E of t is the average, very good, total time. Total time. In what units? In second. So when you get what? Average, everything is average. Everything is average. This is the average arrival rate in packets per second multiplied by what? The average time spent in the what? In the system. This is on the long run. On the long run. Average over a long period of time. That's why we say steady state. Clear? Clear? What are we looking at here? Which part in here are we looking at when we write this equation? Which part am I looking at? Am I looking at the queue? Am I looking at the server? Or am I looking at the whole thing? I'm looking at the whole thing. Now, apply the same formula only on the queue. Only on the queue. Apply the entire formula, the Little's formula on the queue. What will it be? Let's see if you can tell me. E of what? NW. What is E of NW? Is the average number of packets waiting in the queue. Average number of packets waiting in the queue is equal to what? Lambda times what? The expected value of what? W. Are you following? The average what? Average time spent in the what? In the queue. Waiting. Waiting in the queue. Not in the overall system. Where am I applying the formula here? Little's formula. On which part? Only on the queue. Only on the queue part. Now, can I apply it on the server side? And so what will it be? E of what? NS, which is the average number of packets being served. The average number of packets being served. What is it equal to? Lambda times what? E of what? S. Again, the lambda is the average arrival rate, and E of S is what? Is the average service time. Clear? The average service time. Clear? Where is this one applied? This one applied to the server only. And that's why I told you Little's formula is applied on every part of what? Of the queue. On the long run. On the long run. Clear? These formulas are what? are very useful. Why? Because we only need to calculate one of them, and then from them, we can calculate what? We can calculate all the other averages that we are interested in. Because we know a relationship. For example, what is E of n? E of n is equal to what? E of nw plus what? E of ns. Same thing with the t. E of t is equal to what? E of w plus what? E of s. So once we know one, we can what? We can evaluate all the others using Little's formula. Clear so far? Okay. Let's see if you can help me now. Let's start with a simple model, very simple model. You have seen it and before, either in the discussion session or 503. Let's look at it. M1. Okay, now remember the notation. This is the notation that I was telling you about. Now when you see M stands for what? Markovian process, or the memoryless property. Now what does M stand for? M means what? Boson arrival. Listen to me from last time. When the arrivals are boson, what is the inter-arrival times? Exponential. So when you say, and the exponential has the what? Has the memoryless property. So when we say boson arrival, it is the same as saying what? Exponential inter-arrival times. Clear? Okay. M here is what? Exponential service time. Exponential service time. Clear? Okay. The one, what is the one here? Single server. We have just a single server. Clear? Now, where are the other three, the other parameters? Those other parameters. Usually they don't write it. So, in here, what am I assuming the K? I'm assuming that this is a what? Infinite size Q. Clear? Infinite size Q. I am going to assume that what? The discipline is what? First come, first serve. Clear? First come, first serve. And I'm going to assume that the population is what? Infinite. The packets can come from what? Infinite sources. Okay. Let's see if you can help me. Okay. It is desired to find the distribution of N of T of W and so on and so forth, and their expectations. One more time. What is N inverse? N inverse is the number of packets in the system, both waiting and being what? So T is the what? Is the total time spent in the system, both waiting and being what? So W is what? Time waiting in the queue. Notice, by the way, I did not write S. Why? Why I did not write S? I know already S is what? Exponential, which means what? What is this? Fs of T. What is this? What do I call the F? That's the PDF. The probability density function is what? Mu minus e to the minus mu t. T greater than or equal to 0. Clear? Clear? Okay. So let's start with define the state N as what? As the so-called what? State of the Markov chain. How many states do we have? How many values can N take? How many values? One more time. What is N? N is the total number of packets in the system, both waiting and being what? Served. How many values can it take? Infinite number of values. Why? Because I am assuming the size of the queue is what? Infinite. I am modeling at what? As an infinite size queue. So we do have the state. What are the state? 0, 1, 2, it goes on and on and on. Are you following me on now? No response. What is this zero means? When I say zero, what does this mean? The queuing system is what? Empty. Both the queue and the what? Server. Nobody is there. Nobody can. No packet arrived. Okay. Now, if there is no packet, and suddenly it became what? One packet, which means what? An arrival process occurred. An arrival process occurred. How did you go from 0 to 1? If you go from 0 to 1 means what? An arrival process occurred. The average arrival rate is what? Lambda. So we write a transition from 0 to 1 with lambda is the what? Average arrival rate. Clear? Okay. Now, if you are in 1, can you go to 0? What happened? That packet that entered the system has finished what? Has finished service. The server finished with it. Clear? And what happens to that packet? That packet exited the system. Exited the system. At what rate? At what rate? At a rate of mu, which mu is, what is the mu? One more time. What is the mu? Average what? Service what? Rate. Not average service time. Average service rate. The average service time is 1 over mu. So it's what? Average service rate. So this one we have what? Mu. Clear? Okay, let's continue. What do I have here? Lambda. Now, what am I assuming here? I am assuming that the arrivals are independent on the state of the system. Are you following that? In other words, see, this is not always the case. Let me give you an example. Suppose there is a movie playing, some famous movie, let's say the Hunger Games, and you go to try to see the movie, and you see a long what? A long line. Yes? Could you change your mind? Could you get discouraged from entering the system? If you see a long line all the way to the what? To the curve, and you say what? You say, I'm going to what? I'm going to wait all of this to see a movie? You will what? You will say what? Some other time. Clear? What do we say? We say in this case, the arrival process depended on what? How many packets are there, or how many people are standing in what? In line. In here, what am I assuming? I'm assuming that the arrival process does not depend on what? On the current state of the queue. They are always going to what? Coming and enter the queue. Clear? So you go from 1 to 2, what happened? In order to go from 1 to 2, what happened? An arrival process occurred. Yes? Okay. Now, answer me the following question. What is this? Notice, by the way, what does 2 means? There are 2 packets in the system. Remember, this is a single server case. So which means what? It means we have 1 packet in service, and the other packet is what? Is waiting. Now, could this one go back to here? What does that imply? What does that imply? The packet that was in service, finished service. The packet that was waiting started what? Service. And the queue now is what? The queue, the waiting is what? Empty. Are you following me? But there is only 1 packet in the system. That packet is the one that is being what? Served. And what is the rate in here? That's still mu. Are you following me so far or not? Okay, good. And by the way, will this one be the same? This one's 3. Is it the same? Lambda and what? Mu. And so on and so forth. This one continue like this. The chain will go from one state to another state and so on and so forth. Clear? Are you following me so far or not? Okay, good. Now, we write the steady state. Equilibrium. Let's look at it in this way. During this transition, what do I have? Lambda times what? P0. What does P0 stands for? Probability that the queue is what? Empty. The probability that you are in this state. The probability that you are in a state multiplied by what? The average arrival rate should be equal to what? Mu times what? P1. In other words, think about this as what? The boundary. Arrivals, this one is what? Departures. Did you get this or not? Okay, so this equation, which means what? P1 equal to what? Lambda over mu times what? P0. Okay, next, let's look at here. what do I have? Lambda P1 equal to what? Mu P2. Did you answer where this came from? Everybody? Everybody? Okay, so in here the equilibrium is lambda times P1 equal to what? Mu times what? P2. Which means what? P2 equal to what? Lambda over mu times what? P1. But P1 equal to what? Lambda over mu times what? Which means what? This one is square times what? P0. Clear? One more before we generalize it. One more. What is it? Lambda
Time is 18 o'clock.
P2 equal to what? Mu P3, which means what? P3 equal to what? Lambda over mu divide times what? P2. But P2 is this, so this one is what? 3 P0. Clear? Do you see a pattern? Do you see a pattern? So what is it? P of n. What is this in words? In words, what is it? This is the probability that the number of packets in the system is equal to what? N. This is what you refer to it in 543 as what? PMF. PMF stands for what? The probability mass function. The probability mass function. Why? Because n is a discrete random variable. N is a discrete random variable. What is this? Give it to me. Lambda over mu to the what? N times what? P0. Clear? Clear? Okay. Now, I still have what? I still have an unknown in the equation. What is the unknown? What is the unknown is what? It's P0. I don't know what P0 is. One more time. In words, what is P0? In words, is the probability that the system is what? Empty. Notice, by the way, if the system is empty, that means what? The server is what? Idle. You agree? The system is empty. There is no packets in the system, which means the server is what? Is idle. Taking a break. Think about it this way. Clear? Okay. Now, but what do I know? I know that the sum of the PMF, has to be equal to what? Has to be equal to 1. And the probabilities has to be equal to, you either in what? In a state 0 or a state 1 or a state 2 and so on and so forth. There is no other way. Clear? Okay. Which means what? It means that, can I get the P0 outside? P0, can I get it outside? I'd say it's constant. P0 is equal to what? 1 over the summation of what? Lambda over mu to the what? N equal to 0 to what? Infinity. Clear? No response. Clear? Okay. Now, aside. Have you seen this sum before? Have you seen this sum before? A to the n from 0 to infinity. Have you seen this sum before? Okay. Now, when you are dealing, always remember, when you are dealing with infinite sum, is this an infinite series? You need to worry about whether the series converges or what? Diverge. If the series is a finite series means what? For example, n equal to 0 to what? To, let's say, 10. I don't worry about what? Convergence and divergence. The series will always what? Converge. But if the series is infinite series, I need to worry about whether the series converge or diverge. Now, have you seen this series before? What is it equal to? When will it converge? And if it converges, to what value does it converge? It converges to what? 1 over what? 1 minus a, provided what? No. Absolute value of a less than what? Less than 1. Clear? Absolute value. In other words, a could be what? Negative, but as, and by the way, when I say absolute value of a less than 1 means what? Means a between what? Minus 1 and 1. 1 is not included. This is not less than or equal. It's just less. Listen to me. Assume a is equal to 1. What is the series? Assume a is equal to 1. What is the value of this series? Infinity. You will have what? 1 plus 1 plus 1 plus 1 infinity. The series will diverge. Clear? No response. Clear? Oh. Now, I want the series to diverge. Why? Did I say I want the series to diverge? I'm sorry. I want the series to what? Converge. Why? Listen to me, what? If this series diverge, which means what? This is equal to infinity. What is the probability? What is P0 equal to? 0, which means what? What is the probability that the server is idle? 0, which means what? The server will never be what? Idle. The server will break down. Imagine, listen to me, imagine if you go to what? A bank or something like that, and the teller is never idle, working what? Never idle, never take a break. Will the teller break down? You think about it. If you don't sleep, if you don't take a break or something, will you break down? You break down. I'm not sure you are following me. Are you following me or not? I'm not sure. Are you following me? I say, you cannot say that the server is continuously what? Working. You need to take a break once in a while. Clear? Okay. So the series diverge. Now, if it is divergent, so what is it? What is the A in here? What is the A in here? It's lambda over what? Mu. I need to make sure that lambda, in other words, help me. This is what? 1 over 1 minus lambda over what? Mu. Yes? Provided what? That lambda over mu is what? Less than 1. Clear? Clear? Notice, by the way, I don't worry about what greater than what? Minus 1. Lambda over mu are both what? Are both positive. So when you say lambda over mu less than 1, it means what? Between 0 and 1. Did you get my point or not? Okay. Now, define rho to be equal to what? Lambda over what? Mu. Clear? So what did we get? We got P0, which is what? The probability that the server is what? Idle is what? 1 minus what? Rho. Clear? I want you to understand the meaning of this equation or the meaning of this result. I am saying the probability that the server is idle is what? 1 minus rho. What is rho? It's, no, I don't want you to tell me server idle. I want you to tell me in terms of probability. P0 is what? 1 minus rho. The probability that the server, see, the server, listen to me, the server is either what? Busy or what? Idle. There is no other way about it. Clear? It's either busy or idle. This is not the multiple server case. In the multiple server case, the situation will change. This is a single server. The server is either busy or what? Idle. The probability that it's idle, it's what? 1 minus rho. What is the probability that it's busy? Rho. Which means what? Rho represents what? The percentage of time that the server is what? Is busy. Clear? That is what we defined as what? As the server utilization. When I say server utilization means what? The server is actually what? Busy. It's actually utilized. Clear? Clear? Okay, good. So now, this is number 2. Now, what do we have? We go back to number 1, and we said Pn, which is the probability that n equal to n, is what? What is the lambda over mu times to the n? Is what? Rho to the n times what? 1 minus rho. Clear? Clear? Okay. Now, question. Have you seen this distribution before? This is a PMF. This is a PMF. Clear? The PMF of what? Of the number of packets in the system, both waiting and being what? Served. Have you seen this type of distribution before? And if yes, what did you call it? That's a geometric distribution, which means what? Hence, n is what? N, which is the number of packets in system, is geometrically distributed. Clear? Geometrically distributed. A geometric random variable, is it discrete or continuous? Discrete, of course discrete. N is discrete. Clear? Are you losing me? Okay, good. Now, can we find the mean? Can we find the mean? E of N. Still waiting. Equation. Don't give me the answer. By the way, the answers I will post properties of all of these famous distributions, their means and stuff, so that you can use them in the test or in the homework. But right now, I want to make sure you know how to calculate them. How do you get the E of N? Is it discrete? So how do you get the expectation of a discrete random variable? It's summation of what? N times what? The probability that N equal to what? N. N goes from what? 0 to infinity. And that's equal to what? Summation. N equal to 0 to infinity. N times what? Rho to the N times what? 1 minus rho. Clear? Clear? Question. Can I get the 1 minus rho outside? I can get the 1 minus rho outside. Why? Because the summation is with respect to N. So what do I get? I get 1 minus rho summation of N equal to 0. N rho to the N. Now look at as a trick. This is a trick that you will use a lot in the in modeling or in Tune. So I need you to understand when you see something like this. By the way, this is not the same as this. Do you agree? This series is not the same as this series. This series is what? Is A to the N, whereas this one is what? N rho to the N. Clear? Oh, now, what do I can write? I can write this one like follows. Let me write it down and then I'll explain it. D by D rho summation of N equal to 0 to infinity rho to the N. I want you to understand, sorry. D by D rho. I want you to understand one thing here. I'll explain to you where this rho came from. Concentrate. Is this 1 minus rho, 1 minus rho? 1 minus rho, 1 minus rho. Don't worry about this. Don't worry about this. This summation is this summation. Yes? Okay. What is the derivative of this with respect to rho? It's N times what? Rho to the what? N minus 1. In here I have what? N rho to the N. In here I have what? N rho to the N minus 1. So there is a term what? Rho to the what? Minus 1. That term was not in here. Yes? I multiplied by what? Rho. So they cancel. Did you get it? Did you get how did I get from here to here? Yes? Or you lost me? You lost me. What is D by D rho? Rho to the N is what? N rho to the N minus 1. Yes? Which is what? N rho to the N times what? Rho to the minus 1. Agree? This is only what? N rho to the N. Yes? In here I have what? N rho to the N, rho to the minus 1. So I need to multiply by what? Rho. So that this one will cancel. Clear? Oh, but rho is constant, so I get it outside. This is this rho. Clear? Okay. Next question. Can I interchange the order of summation and differentiation? Why? Why I can do that? The summation is with respect to what? N. Whereas the differentiation is with respect to what? Rho. So I write it like this. 1 minus rho times what? Rho times D by D rho of what? Summation rho to the N. N equal to 0 to infinity. Clear? Clear? Okay. Now, is this similar to this? That's similar to this. So what do I have? I have 1 minus rho times what? Rho times what? 1, times. I'm sorry. Rho times what? 1 minus rho times D by D rho. 1 over 1 minus rho. Did you answer where this came from? Am I going fast or you are following me? Okay, this is this summation. Provided what? Rho is what? Less than 1. We already know that rho is less than 1. Okay. Now, what is the derivative of this with respect to rho? 1 over 1 minus rho square. One of them will cancel with this, and I end up with what? Rho over what? 1 minus rho. That's E of n. One more time. What is this in words? What is this in words? This is the average number of packets in the system, both waiting and being what? Served. Clear? Question. What if rho approaches 1? What does this tell you? If rho approaches 1, remember rho is less than 1, but if it approaches 1, what does this one approach to? It will approach infinity, which means the system is going to be what? Unstable. It will lose its stability. Do you follow me? So there are infinite number of what? Infinite number of packets in the system. Remember, only one of them is being what? Served. All the others are what? Waiting in line. Did you get this or not? Okay. Now, what is E of t? First of all, in words. What is E of t in words? Is the expected time spent in the system by a packet, an arbitrary packet. Average time spent in the system, both waiting and being served. What is it? Using little theorem, which is what? E of n over what? Lambda, which is what? Rho over what? Lambda 1 minus rho, which is equal to what? Now, what is rho? Lambda over what? Mu. The lambda will cancel with this lambda. Yes? So what do I have? 1 over mu 1 minus lambda over what? Mu, which is what? 1 over mu minus lambda. Did you get where this came from? Yes or no? Okay, good. Now, this is E of t. Now, let's see if you can help me. What is E of s? What is E of s? This is the average service time. This one I already know. Why? Because the service time is what? It's exponential. So what is it? E of s is what? 1 over mu. Clear? Okay. What is this? I want you to tell me what is this, first of all, in words. This is the average number of packets being what? Served. Notice, by the way, how many servers do we have? 1. If somebody asks you, what is the average number of packets being served? You cannot say what? 1. Because if you say 1, that implies that the server is always what? Busy. But the server is not necessarily always busy. Clear? Okay. What is it? From little theorem. It's lambda times what? E of s. Which is what? Lambda over what? Which is rho. Does this result make sense? This result makes sense because we defined rho as the what? As the server utilization. Server utilization is what? The percentage of time that the server is what? Is busy. Clear? Okay. What is E of NW? What is E of NW? It's what? It's E of N minus E of what? NS. Which is what? What is E of N? Rho 1 minus rho minus what? Rho. Which is what? Help me. Rho square over what? 1 minus rho. Clear? Clear? Did you answer where this came from? What common denominator is what? 1 minus rho, so you have what? Rho minus 1 minus rho times rho, and the rho's cancel, you get this. Okay, and finally, we have one more parameter. What is that? E of what? E of what? W. What is E of W? It's E of what? T minus what? E of S, which is what? 1 over mu minus lambda minus 1 over what? Mu. Clear? Clear? Okay, question by the way. Is this positive or negative? How could it be negative? Which one is bigger, this one or this one? This one is bigger than this one. You follow me or not? Now, I want you to go back to this equation. By the way, this is the major equation for us. If lambda approaches mu, if lambda approaches mu, which is the same as saying what? Rho approaches what? 1. What would E of t approach? Infinity. And that's the curve that I showed you last time in the notes, where you do have the pulse. This one will go to what? Infinity when it reaches rho equal to what? 1. The average delay is what? Is 1. By the way, is there a loss? Where? How do you lose packets? We are assuming that the queue size is equal to what? Infinity. This is a delayed system. It's not a loss system. I'm not sure. Did you get my point? Did you get my point or not? Are you losing me? You are looking at me strangely. Are you following me? Is this a loss system or a delayed system? Delay system. There will be no packets that are what? Dropped. Why? Because we are assuming that the size of the queue is what? Infinity. Clear? So the delay will go to what? The delay will go to infinity. Are you following? The delay will go to infinity. Good or bad? Yes, of course it's bad. So you need to make sure that the arrivals are what? If the average arrival rate is less than the what? The average service rate. Clear? Okay. Now all of these that we calculated, can you zoom back just a little bit, Jonathan? Thank you. All of these that we calculated are averages. Are averages. Can we get the distribution? Which one is a stronger description of a random variable? The average or the distribution? Of course the distribution. From the distribution, you can get the what? The average. From the average, you cannot get the what? You cannot get the distribution. Clear? So the question is what? Can we get the distribution? Clear? Let's see if you can help me. That where it gets a little bit sticky. Let's see if you can help me. Can we get the distribution of T? What is T? Total time spent in the system, both waiting and being what? Served. And W. What is W? The time spent waiting. The time spent waiting. Okay. And the answer is what? Answer is what? Of course, yes, but complicated. I don't want to say complicated. Yes. Let's hope you can follow me. Now, concentrate on T first of all, the total time. Notice, by the way, when we say distribution, what does it mean? I.e., what am I talking about? Am I talking about PMF? No, I'm not talking about PMF. Why? Because T is what type of a random variable? Continuous. So I'm talking about what? The CDF. What does the CDF stands for? Cumulative distribution function, or what? PDF, the probability density function. Either one of these is fine. Clear? T is a continuous random variable. It's not a discrete random variable. N, on the other hand, N, which is the total number of packets in the system, is what? It's a discrete random variable. That's why we found the PMF. Help me now. Let's see if you can help. Assume means what? Given that there are N packets in the system, i.e., N is equal to what? N. And a packet arrived, and a packet arrived into the system. You are not, concentrate. I am a packet. I arrived into the system. What did I find? I find that there are N packets, small n, in the system. Question, when I tell you given that N is equal to N, is this a random variable or not a random variable anymore? Not a random variable anymore. I'm telling you that there are what? n packets in the system. Clear? How long will this packet wait? How long will this packet, the one that just arrived, how long does it take for this packet to leave the system? Leave the system means what? Finish the waiting time and finish the what? The service. Clear? What does he have to wait? Oh, sorry, how long does he have to spend? Concentrate. He came into the system, he saw a packet already being what? Served. Does he worry about when did this packet start its service? Why? Because the exponential distribution is what? Memoryless. Are you following that? So he needs to wait for this packet to what? Finish service. He needs to wait for what? N minus 1 other packets who were what? Waiting to finish their service. And then he needs to what? To be served himself. Did you lose me? What do I write then? T is equal to what? What is the T? The T is the time spent in the system by this packet, assuming, given that the number of packets in the system is how much? N. What is he has to wait? He has to wait for what? S1 plus S2 all the way to what? Sn plus what? S. I want you to tell me, what is this S1? What is S1? S1 is the service time. S1 is the service time of the packet that is already in what? That is already in service. Yes or no? What are these? These are the service times of N minus 1 packets that are already what? Waiting. Yes? What is this S? Its own service time. A service time of which packet? The one that just arrived. Clear? No response. Clear? Okay. Every one of these is what? Exponential, independent, random variables. Clear? With what distribution? What distribution? Each one of them. Sorry, I wrote it already. Exponential. Clear? With what rate? What is the service rate for each one of them? Mu. Everyone is mu, mu, mu. Clear so far or not? Clear? Okay, I'm still not sure whether you got why is S1 exponential. S1 is who? Is the service time of the packet that is already in what? In service. When a packet arrives into the system, he doesn't care about what? When did the packet that is already in service has started what? Service. The time that it has spent already servicing that packet who is in the server is irrelevant. Why? Because the exponential has what? Has memoryless property. Are you following? It does not depend on what. When did you start service? You arrived, the packet arrived, you see a packet in service, the service time for that packet is still what? Exponential. Clear? Clear? Okay. Now, I don't expect you to remember what T is. If you do have a sum of exponentials and they are independent, can you tell me what is the PDF of T? Gamma. Very good. Gamma distribution. So what do I say? T, hence. Hence, T is what? Gamma distributed. Let's see if you can help me first of all. Let me write the gamma distribution. How many terms? How many terms do we have? N plus 1 terms. Clear? The gamma distribution is this. Now, I don't want you to memorize this. This, I will give it to you. Mu to the T to the N over what? N factorial. Clear? Okay. I need you to understand one thing here. What did I write here? What did I write here? Mu e to the minus mu t times mu t to the n over n factorial. What did I write? Say that again. Of what? PDF of what? I know it's the PDF of what random variable? Huh? Is that the PDF of T? The PDF of what? No, you lost me here. I can tell you lost me. Concentrate. What are we trying to get? What are we trying to get? We are trying to get the PDF or the CDF, doesn't matter. PDF or the CDF of who? Of capital T, which is what? The total time spent in the system. Yes? Is this it? Is it the gamma distribution? In other words, can I say that T is gamma distributed? No. Why? This is only given the fact that the number of what? The number of packets in the system is what? N. In other words, what did I write? I.e., follow me here. F T given N equal to what? N. Is this a PDF or is it a conditional PDF? Conditional PDF. What I want to find is the what? Is this. I want to find the what? The unconditional PDF. The unconditional PDF of T. This one is what? Conditioned on the fact that there are what? Let me ask you a question. In here, how many terms? N plus 1. Yes? If N is equal to 2, how many terms will I have? 3. If N is equal to 3, how many terms will I have? 4. Am I going to get the same answer or different answer? T is a continuous random. Thank you. Did you bring the tomatoes with you? You answer what tomatoes mean. If I make a big boo-boo, you need to throw tomatoes on me. I'd say, excellent, sir. Excellent comment. My mistake. T greater than or equal to 0. What's 0, 1? Of course not. Did you get my point or not? You are losing me. All of this is 5.3. All of this. Did you take it in 5.3? Yes. So why are you struggling? Okay. Did you? What is this? One more time. What is this? This is the conditional PDF of what? Of the total time given that the number of what? The number of what? The number of packets in the system, both waiting and being served, is what? N. Which is what? One more time. Mu. Clear? Okay. Now what is this? This capital now. This capital T. Give it to me first of all in words. CDF. Conditional CDF. Yes? This is the conditional what? How do I get the conditional CDF? If I have the conditional PDF, forget about conditional. If I have a PDF, how do I get the CDF? Integrate. Yes? If I have conditional PDF, how do I get the conditional CDF? Integrate. So what is it? Give it to me. Integration from where to where? Of what? Why did I change the T into X? Just a dummy? So that what? You lost me here again. I can tell you lost me. One more time. If I tell you this, Ft of T, if this is given, how do you find this? Integration from where to where? You cannot put 0 to infinity. You put 0 to infinity, you get a what? A number. You don't get a function. 0 to T of what? Ft of X dx. What is the X? X is just a dummy variable. Are you following me or not? Yes or no? Okay. Now, is this what I'm looking for? No, this is not what I'm looking for. What am I looking for? I'm looking at this. Ft of t. This is what I'm looking for. Clear? What do I need to do? What do I need to do? This is the conditional, conditioned on what? N. I want the what? Unconditional. What do I need to do? I need to average over what? Of all possible what? N. All possible what? N. And remember, N is a what? Discrete random variable. So what do I write? Summation. N equal to what? 0 to infinity. F t of t given N equal to N times what? No. N is discrete. The probability that N equal to what? N. Clear? Clear? Did you lose me? One more time. Is this conditional? Conditioned on who? Conditioned on N equal to what? Small n. Then I need to average over all possible values of what? N. What are the possible values of N? N equal to what? 0, 1, 2, 3, 4. You follow me or not? I need to average over all possible values of N. And since N is a discrete random variable, so it's what? Summation of this. Clear? Okay. Now what is that equal to? Summation N equal to 0 to infinity, the integral of mu e to the minus mu x to the n over n factorial times. Now what is the probability that n equal to n? The probability that n equal to n is what? Rho to the n times what? 1 minus rho. So it's what? Rho to the n times what? 1 minus rho times what? Dx. From 0 to what? T. Clear? Clear? Okay. Can I interchange the order of summation and integration? Why I can do that? Why I can do that? Summation is with respect to who? N. The integration is with respect to who? X. So I can change. So what will it be? Integral. 0 to t. Now, let's see. Does this one have n in it? This one? Mu e to the minus mu x. Can I get this outside also? Yeah, so it's what? Times what? 1 minus rho. Yes? Can I get this one outside? No, I cannot. Why? Because this one has what? N. So what do I have here? Summation n equal to what? 0 to infinity. What? Tell me. Can I group this with this? This one and this one. Can I group them? So what will it be? Mu x rho to the what? N over what? N factorial. Clear? No response. Clear? And then what? Dx. Clear? Okay. Now, answer me the following question. Have we seen this series before? If I have this series, a to the n over n factorial. That's the what? That's the exponential. A to the n. Yes or no? Okay. Is this? So what do I have? That's equal to integral 0 to t mu e to the minus mu x times what? 1 minus rho times what? Tell me. I'm still waiting. E to the what? Mu x rho and then what? Dx. Clear? Clear? Okay. Can I get the 1 minus rho and the mu outside? So what do I have? Mu. Remember, what am I calculating? Ft of t, which is what? In words. What is it? That's the CDF, not the conditional, unconditional. CDF of the total time. Clear? Okay. What is what? Mu times what? What remains? 0 to t. Can I group this with this? So what do I get? E to the minus mu x times what? Help me. 1 minus rho dx. Clear? Clear? Now, what is the integral of this? The derivative is already what? Is already here. Do you agree? Okay, all what I need is a what? Is a negative sign. Yes or no? So what is it? You lost me here. What is the derivative of, sorry, what is the integral of this? The derivative of this is already here. Yes? So what is it? E to the minus mu x 1 minus rho from where to where? No, t to 0. Why? Because there is a minus sign in here. So I switched the limits of integration. Clear? Which is equal to what? What is it equal to? 1 minus e to the minus mu 1 minus rho times what? T. Did you get this or not? Which is equal to 1 minus. Now what is rho? Lambda over what? Mu. The mu cancels with this, so what do I end up with? E to the minus mu minus lambda times what? T. Did you get it? No response. Did you get it? Okay. Which means what? What is ft of t? Give me f2 of t. ft of t is the derivative of this guy. Yes? It's mu minus lambda times what? E to the minus mu minus lambda t. T greater than or equal to 0. Clear? Conclusion. I wanted to conclude. What is t? The t is exponential. The t, hence, t is what? Exponentially distributed. What is the mean of t? What is the mean of t? If it is this exponential distributed, what is the mean of t? 1 over mu minus what? Is that the same result that we got earlier from Little's formula? Where is Little's formula? Little's formula. Did you get my point or not? Yes or no? Little's formula is very useful to get you what? The expectation. But from the expectation, did you know that it was exponential? You did not know that it was exponential. But when you derived it and you found it to be exponential, you got the same what? You got the same result from Little's theorem. Clear? Clear? Okay. Now, let's see if you can help me with the next one. Which is what? What about W? What is W? What is W? Waiting time. Now, answer me the following question before I show you the procedure. The procedure, by the way, is similar to this. Let's see if you can tell me the procedure. Sorry, let me see if you can answer me the question. We just found that t is what? What is t, capital T? It's exponential. Yes? We already know that the surface is also what? Exponential. Agree? Is W exponential? What do you think intuitively? Will W be also exponential? Say something. Say something. You are not thinking clearly. You are not thinking clearly. If you tell me it's exponential, it means you are not thinking clearly. Let me ask you a question. I think I already asked you that question last time, but you forgot. What do I mean by a continuous random variable? If I say that this random variable is continuous, if I tell you that x is continuous, what does it mean? It means that the probability that x takes on any specific value is equal to what? 0. That's what a continuous random variable means. The probability that x takes on any specific value equal to what? 0. W. Is it a continuous random variable or not really? Why? Is it possible that an arriving packet does not wait? When? When the server is what? Idle. You cannot tell me when the server is serving one packet. If the server is serving one packet, what does that mean? It means that you have an arriving packet has to what? Has to wait. Are you following on that? What is the probability that W equal to 0? Is the same as the probability that N equal to what? 0. Do you agree? You are not going, an arriving packet will not wait if the system is what? Is idle. Clear? What is that equal to? Agree? What does that tell you? What does this statement, what does it right away tell you? It tells you that W is not a what? Exponential distributed. Why? Because if it is exponential distributed, what does it mean? It should be what? The probability that the random variable takes on any specific value equal to what? 0. But it's not. Are you following me on that? It's not. Is it discrete? Is W discrete? No, it's not discrete. So if it is not discrete and if it is not continuous, then what it is? It's mixed. Mixed means what? It can take some discrete values and it can take also what? Infinitely uncountable number of values. Clear? Oh, so we say what? Now, let's see if for W greater than 0. For W greater than 0, which means what? There is waiting. Let's see how we approach it. An arriving packet arrived to the what? System. With the same idea. What did we do here? To find T, to find the PDF of T. What did I say? Given that there are what? N packets in the system. Yes? How much will he wait? In other words, given that N is what? Equal to N. How much is W? What will he wait for? There are N packets in the system when he arrives. How long will he wait? He will wait for the packet which is in service to finish service, and then he has to wait for what? All other N-1 packets that are in the system to exit. Write it for me. What is it? Agree? Is there another term? No, there is no other term. Remember in the previous one? What was it in the previous one? How many terms were there? N plus 1 terms. In here, how many terms are there? N terms. But this is still, they are what? Independent and what? Exponentially distributed. Yes? What is this will be? It will also be gamma. Are you following? It will also be gamma. But instead of what? Instead of N, it will be what? N-1. Tell me, what do I write? Let's see if you can tell me, what do I write? F, look how I write it. Look at me. F of T, so F of what? W of T given N equal to what? N, yes? N equal to N, and W is what? Greater than 0. This is for the case W is greater than 0, is equal to what? Mu e to the minus mu t times what? Mu t to the N-1 over what? N-1 factorial. This is the what? Gamma. Thank you. Did you lose me? Did you lose me? Look at this and look at this. This is for the total time. This is the waiting time. Mu e to the minus mu t, instead of mu t to the n over n factorial, is what? Mu t to the n minus 1 over what? N minus 1 factorial. Yes or no? Cannot hear you. Okay, now what is this? What is this equal to? This is the conditional what? Conditional CDF. Yes? What is it equal to? Agree. It's just simply the integration of the conditional PDF. Yes? Okay. But I don't want conditional. I don't want conditioned on n. I need to average over all possible values of what? N. So what do I do? What do I write? I need to average over all possible values of n. Yes? Yes? Where? From where to where? N equal to 1 to infinity. Whereas in the previous one, look at the previous one, n equal to what? 0 to infinity. How come this one is n equal to 1 to infinity? If n is equal to 0, it means what? W equal to what? 0, which is not part of this. Did you get this or not? This is n equal to what? So what is this? Again, I'm going to interchange the order. Times what? Clear? Clear? Did you understand? How did I get this? It's the same thing. It's the same here. I wrote it and then I interchanged the order. So it's what? Mu e to the minus mu x. So I have the times what? Rho. I'll explain this one to you in just a second. Did you understand this? Is this the same as this? Dx, sorry, dx. Is this the same as this? This one. Is it the same as this one? Oh, 1 minus rho, I get it outside. Yes? Where is this rho came from? Where is this rho to the n? I wrote it as what? Rho to the n minus 1 times what? Times rho. Yes? The rho is this one. And the rho to the n minus 1, I grouped it with this. Yes? Mu e to the minus mu x times what? What is this? Let L equal to what? N minus 1. So this one is what? Mu x rho to the what? L over what? L factorial. So this one is the same as what? Agree? Okay, I'm running out of time. Let me write the final equation. Fw of t is what? Is Fw of t given W equal to 0 times the probability that W equal to 0 plus Fw of t given W greater than 0 times the probability of what? W greater than 0. This is the total. What is this? Yeah, okay, we'll continue next time. We'll continue next time. I ran out of time. Next time means tomorrow, by the way. Next time tomorrow. In the review, I'm going to continue with this. I don't want to spend the next week on this. I will finish it tomorrow. Clear? Cut me off. Cut me off. Did you follow me?